Hello everyone. So in this video, we will see why we need to use a Docker and what problem it's going to solve. So let's take a development environment. So in a development environment, the developer creates a new application or adds a new feature to the existing application. So when they completed the application has to be tested by the tester and has to be deployed to the client machine by the deployment team. So um, normally the application works fine. So imagine if it's a very complicated application with a lots of dependencies on configuration. So if this is just a code change, it will work fine. But what happens if the developer adds some new dependencies or added some new configuration? For example, if it's a .NET application, if the developer upgraded the .NET framework, or if it's a Java application, if the developer upgraded the Java version, then the tester and the deployment team has to do the same change to make the application running in their machine. So it's not only about the framework upgrade but also about the dependencies and configuration. So if the developer haven't communicated the configuration very well, then the tester may not know about it, and the application will work in the developer machine but it won't work in the tester or deployment machine. And also the developer only knows about the configuration and the tester and deployment team have no idea about the configuration. So this involves lots of time consumption and waste of time. So this is where the Docker comes in. So with Docker, let's imagine the developer makes a single page application. So the single page application is done using Angular with .NET as a backend and MongoDB as a database. So this is a dependency for developing the single page application. So with Docker, all these dependencies and configuration will go inside a Docker container, and the deployment or testing team, they will just pull this container as a Docker image in their machine and they just run it, and all the dependencies and everything will be available in the Docker image and it will just start the application. They don't have to do any configuration. um, so so you can see that when the developer completed the changes, the tester and deployment team only gets a Docker image which has got the application and all the dependencies and configuration inside of it. They just need to get this Docker image and just need to run it. So when they run this Docker image, it will start as a Docker container in their machine. So we will see a simple workflow of how this Docker build is done and how this Docker image gets generated. So in this workflow, we will see about different steps involved in getting the application running as a Docker container in the tester or deployment machine. So at the initial step, the developer makes some change to the application. This change could be adding a new dependency or adding a new library or making some new configuration to the existing application. So once changes is done, the developer pushes the changes to the source control like GitHub or Perforce or TFS or Subversion. So once the changes is available in the source control, then the Docker build is done. So the Docker build could be done locally in the developer machine as well, but in most cases, whenever there is a new changes pushed into the GitHub, it will trigger a Docker build in the pipelines like Jenkins. So this Jenkins do the Docker build. So when the Docker build is done, the Docker will bundles up the entire application with all its dependencies and configuration into a single image. So which is basically a single file. So when in case if the developer do the Docker build locally, it will still do the same step and generates a Docker image. So once the Docker image gets generated, this can be pushed into the Docker hub. So it could be pushed to the private or public repository. So if the application is in the AWS or Azure, then this image can be pushed into the Docker registry in the AWS or Azure. So once it is available in the Docker Hub, any team member can able to pull this image. So when they pull this image, they can do a docker run command, which will start running the application as a Docker container in their machine. So now this container will have the changes done by the developer. So now the tester or deployment team member doesn't have to worry about any configuration or any dependencies which the developer has made. They just do only their job, like the deployment team do the deployment job, and testing team just only focused on testing. They don't have to worry about all this configuration and other dependencies. And also the application will behave the same like how it behaved in the developer machine. So when looking at the Docker structure, we have the computer hardware. The computer hardware includes the hard disk and RAM and other parts of the computer. And then on top of that, we got that operating system installed. The operating system could be a Windows, Mac, or Linux operating system, anything you can imagine. And then on top of the operating system, we have the Docker. We install the Docker. So when installing Docker, it also installs a Docker daemon service. So the Docker daemon service is a core part of the Docker. So this daemon service manages all the Docker objects such as container, images, and everything. And whenever we run a Docker command, the Docker daemon actually processes it. So we got the Docker client. So whenever we run any Docker command, the command passes through the Docker client, and then the Docker client sends a HTTP request to the Docker daemon about the command, and then the Docker daemon actually processes it. On top of the Docker daemon, the containers are running. Like we see in the previous video, container have the application and dependencies and configuration, everything. So all these containers running on the Docker container are all isolated to each other and also isolated to the host operating system. So which means if an application, say if it's a web application and it requires a node version 8, and then another application needs a node version 12, then these two applications runs in a separate container, and then it has got its own dependency as well. So the container 1 dependency, node 8 dependency won't interfere with the container 2 node dependency. So it's all isolated to each other. And then when comparing, also when we can run multiple containers at the same time. So now we will see about the difference between the Docker structure and the visualization software. So when comparing the structure of virtual machines on Docker, we got pretty much same, but there are some difference. So we got the same computer hardware. On top of the computer hardware, we got the hypervisor. The hypervisor makes a virtualization possible. And then on top of the hypervisor, we'll have operating system installed. Many operating system. We can have multiple operating system, for example. So and they are all called as guest OS in virtualization. And this operating systems shares the computer hardware. For example, if the computer has got like 16 GB RAM or maybe like 36 GB RAM, those 36 GB RAM shares between these guest OS. So now on top of the guest OS, we can have our application running. So just in case if the computer hardware has got some issues, or if it have any faulty things, then what we simply do is we just use we convert the guest OS into an image, and then we can run this on a different hypervisor running on different computer hardware. So it's very simple, but just for running the application, we transfer the entire operating system here. It might take some time to transfer this guest OS to a different hypervisor and start running on it. It might take some minutes. So, but in case of Docker, the Docker shares the operating system kernel. So each container running its application shares the operating system. So whenever we wanted to share the application to different users, then we just simply make a Docker image of the running container and then give the image to the different person, and then they can run the Docker command, Docker run command, to get the container running from the image. So it's very simple and it takes only millisecond. So this is the basic difference between virtual machines and the Docker. As you can see by now, Docker has got a lot of advantages. If you are using Docker, shipping the application is much more easier to different team members or to a different machine. All they need is a Docker installed on the target machines. They don't have to do any manual install of the software dependencies to run the application. The application behaves same in all the environment, and they can also run the same application in multiple containers, and they're all isolated to each other. In the next video, we will look into more detail about how to run a container from image and how to package an application and its dependency as a Docker image and various other Docker commands. If you like this video, please subscribe to our channel, as I will be posting many more videos like this. Thanks, bye.